Hello YouTube, De-bodgery here. So I have put my macro lens on, and now the camera lens is about 4 inches away from the circuit board. And you are right now, sorry for the motion, come on camera, stabilize. You are right now looking at the MCU or processor, and there we go, you can see it. Yeah, light off the thing is kind of hard. But as you can see, that says STM32 F1003, whatever that is, C8T6, I think. Anyway, that's kind of the low-end STM32 processor that you can get. It is theoretically possible to put a very basic FOC function set in there, but it lacks the processing power to be able to handle that particularly well, and it certainly lacks the processing power for the full FOC suite, say like VESC, which is why this little guy is not used on VESC controllers. It's simply not powerful enough. Here is the Bluetooth module, and in my previous video I talked about how it cannot handle vibration very well. And as you can see, here's a little bit of silicone on it, and I will just press on the corner. Yeah, you can see it flexing, and I'm using the tip of my fingernail and very little pressure. That board is going to vibrate like that, and all it's held in place with to keep it from moving is a little bit of silicone and the 4 solder pins over here. So that's going to move. That's going to be a failure waiting to happen, and it's going to stress those solder pads right there and slowly break them off, and then you won't have Bluetooth connectivity to your KO controller. Alright, down a little bit further. So, yeah, there we go. You can see the little linear hall right there, and that's what's sensing current. So this is just ferrox core with a slot cut in it. And it's creating a magnetic field that little linear hall is detecting. And I don't know how well that shows up in camera, but there we go. You can see the part number on there. So anyway, it's just a linear hall, nothing really special. Wherever it is, there she is. So that little guy right there, and let me tilt the camera so you can see. Nope, the camera is not cooperating. Anyway, yeah, that is a 3.3 volt linear regulator right there. Rotate the board. So here is one of your 3 high side and low side MOSFET drivers, and yeah, I can't see the part number myself. And anyway, yeah, now I can kind of read it. Let me try to bring it in a little closer so you can see it on camera, if the camera will focus. Come on. There we go. So EC21810, looks like 81D, 810. Yeah. There we go. Yeah, EG2181D. I don't know who makes that part. And let's go over here a little bit. So here is, yeah, there's other 2 MOSFET drivers right there. And here is your DC to DC section I talked about before. So this right here is a 7805 5 volt linear regulator, and then this section right here is your DC to DC converter, and probably it's making 12 volts. That's a pretty common voltage for this kind of application. So pretty standard stuff. You can see one of those areas, so you got this area in the middle where there is no circuit trace, and then all these via holes around it to add a little bit more current carrying for that right there, and that is a battery minus. And here is all of your pins. And what you're seeing here is just silicone. That is not a gasket in any way. It is just silicone that is poured on the board, and then the plastic case is stuck down on it while the silicone is yet to cure, and completes the seal. This little component here, and let's see if we can't get it a little closer, see what that is. My camera, focus. Come on. Camera is not cooperating. So anyway, as you can see, that is hand soldered. Yeah, it is not. Yeah, there we go. Now you can see the part number on there. Yeah, Max 485. I don't know what that is. I have to look up these parts, but as you can see, that's hand soldered. So my guess is either this part was defective, wasn't soldered down particularly well, but straight from the factory, because this is a brand spanking new controller, it was already repaired. I don't know what these are. Hey, you see those right there? 3 little solder bridges. Yeah, was that like a patch? Don't know. Don't know what those are for. Yeah, it's kind of odd. And right next to them, you can see those resistors are also hand soldered. So repair work was done on this board straight from the factory. You can see that they are not your typical reflow solder work, and they've got flux around them. Yeah, those are all hand soldered resistors. So some kind of rework was done to this board after it was originally manufactured. Maybe the original parts are put there with the wrong value or something like that. I don't know the answer to that question, but yeah, you can see those resistors don't lay flat, and the solder blobs on them are, well, not reflow soldering work. That's something else. So yeah, there's details about this board where clearly things got reworked after the fact. Let's see if there's anything else like that that shows up for me. Nothing really coming to mind. This is all pretty fairly standard kind of componentry that you would see in a lot of cheaper quality controllers. This little guy, I don't know what that thing does. Right here. So whatever that is, an 05BB01A. Yeah, I don't know what that is. It's an interesting little part. I'll have to look it up. And same thing for that little chip right there. It's a little 8-pin chip. And again, it looks like it was possibly hand soldered, although I don't see flux around it. I'm going to say that was probably reflow soldered. But yeah, I'd have to look up that part number 2 and find out what it does. Don't know. But yeah, it's, you know, it's a through-hole chip that is surface mounted. So they had to take the legs on the thing, because there's no through holes, and bend them over so that they could surface mount it to the board. But yeah, it's not a surface mount component, which is an interesting use of a part. Don't know why that was. So yeah, like that little guy right there, you know, oops, sorry, bumped the camera. So that's a MOSFET driver, and that's how surface mount parts should be, not standing really proud like that is with its legs bent over. So this is a through-hole component stuck on a surface mount board that should have stuff like these. Yeah, don't know what that was about. Some design choice. Oh, that's interesting. So let me move this board out of the way. Get that underneath the camera. Oh, where'd it go? There it is. See that right there? That was stuck to the board. That's a little dot of solder. That was just, you know, it's like a little drip of solder that was just sitting there on the board. Yep, I just noticed that and popped it off with my spooger tip, which is pretty dull. Yeah, that was a problem waiting to happen for sure, because that would lodge itself God knows where. Let me pull that out of the way and bring the board back under. Yeah, if it lodged itself between any of those little resistors or capacitors or against legs on some chip, yeah, I'm pretty sure that would cause malfunctions, and yet there that was on the circuit board. Where I found it was, so you can see this right here. Oh, that's interesting. So you see those 3 little through holes right there? That's for another current sensor. That would go right here, and that would be where the linear Hall would, and that's on battery plus. Anyway, that little blob of solder was sitting right there where that slightly raised spot is. That's flux on there. But it was stuck to that. But yeah, they actually planned for current sensing on battery plus, which is kind of cool, but obviously they didn't implement it because, well, KO cuts corners. That's what they do. And so, yeah, rather than showing you battery current, they said, nah, we don't need that. That's just an extra part. Let's just leave that out. You have a tweeter on here. I've never run this controller, so I don't know about functionality and stuff like that, but I don't know, does that make a beeping noise like when the controller's overheated? Because I would say it's definitely going to overheat. I don't know what the little tweeter's for, if it even works. Yeah, keep finding interesting things. Oh, shit, look at that. Nice. Super, super cool. Let me grab some tweezers. Oh, wrong ones. There we go. I didn't put this on here. See that right there? That is solder. That was just sitting there on top of those traces. You know, I saw it on the camera. I didn't see it with my eyeballs. I saw it through the camera because that's much closer in. But, you know, it was sitting right there. I didn't put that there. It was already there. So I'm going to hazard a guess that probably this controller was not going to work anyway because, you know, it's not soldered down to anything, but let me pull that out of there. Come on. But that little blob of solder was definitely bridging across some components. There we go. Nice. So 2 solder blobs on this thing. Yeah, you saw it. It was right across those components right there. I have no idea if that was creating an actual short or not, but it was totally loose, just sitting there, waiting to create problems if it wasn't immediately doing so. Jeez. This is a brand new controller. It has never been opened like this before. This was all done by me. And how I know that's the case is because things like that silicone around that connector, you know, this wasn't torn. I had to tear it apart to make that come apart. This repair of that component right there, I opened it up like that. I saw that almost immediately. But like those 2 little solder blobs, I didn't see those until I just started making this video. This is crazy. Everything else looks more or less okay. This is, you know, typical reflow soldering technology here, minus, you know, a few solder blobs. Well, I think that's it for this video. I'll do one for the power stage next.